Welcome everyone. Today we have our another new episode and we will discuss on autonomous system and its social impact. We have our world famous speaker, Mr. David Schumacher, Mr. Marshall, Professor David Smith, and Professor Donald. First, I would like to give chance Mr. David Schumacher.
Yes, hello, Sharif. Love the topic today, autonomous systems, which we've talked about, but I like the idea of taking it from the social impact side. So that's the approach that I've taken to talk about it this morning. Autonomous systems are here. They're starting to be seen around us in the Phoenix, Arizona area where I'm at here. We see autonomous vehicles on the road, and we see some other autonomous systems that are slowly creeping into society. So what do we do about this going forward? I mean, this is going to be part of something in the near term future, and it's going to expand as we go on. And I think we need a way to think about how they are adopted and then how they're integrated into what we're doing. And the idea that I propose is that we look at them as extensions of the legal entities that own them, whether that be a person or a business or any form of legal entity, and that ownership is responsible for them, much the way a parent would be responsible for a child, or the way an employer would be responsible for the work of their employees. And then that ties it back into legal communication systems and so forth that we're all fairly used to. In other words, think of autonomous systems that I might have for my business as one of my employees or an extension of me, and I'm going to interview them, if you will. I'm going to develop them, if you will, as I would a human employee or person, and be responsible for them. We have some examples of that now. I've already mentioned autonomous vehicles, which probably is what comes to most people's mind when they think of autonomous systems. But we've had other systems for years that are slowly integrating this way. We've had a show where we talked about robotics, and I talked about cobots. And cobots are collaborative robots that work hand in hand with the human. Human does a certain part of the job, and the cobot does another part of the job, but the human's responsible for the overall job. So it's that kind of model that I think that would help. So, like in vehicles, the autonomous vehicles that we see here in the Phoenix area are primarily like rideshare or taxi. We can think of them as that nature. But I think very soon we'll start to see delivery vehicles, and those delivery vehicles can be trucks, they can be drones, they can be some combination, but think of them as the delivery system. You've called up and you've ordered material, and somebody drives out to your place and brings it to your door. Well, that's all then being done by various forms of autonomous systems. So think of them as the employee of those companies, and that employee is responsible for their training, their safety, and how they get along. So autonomous systems then need to be developed for decision making. They need a certain amount of socialization. I mean, a driver that just comes up and drops a package off at your door, but they might also say hi, or you have your own personal interaction to seeing this driver come up to your door. When you see something different, that's going to take some socialization on your part and on the part of the system that's doing that. And of course, they need to be confident. That's probably the area that I see as the point of contention for socialization as we move on. It's the human autonomous system interaction. So I'm used to talking to a delivery driver, but I'm not necessarily used to seeing a drone, whether it be rolling on wheels or whether it be flying, that comes up and drops a package at my front door. How do I respond to that? How do I respond to deliveries that look different than what they did before? And we humans have to learn how to adapt to that. So I think if we adopt this type of model that I'm thinking of and that I see that others are thinking of, it helps us work through the ethical issues that come up on how to integrate these systems in here. We have the usual same type of issues adapting to autonomous systems that we do adapting to anything else. There's a little bit of fear that there's something new. Maybe there's people that don't like that and there's some type of conflict and you feel forced to take one side or the other. Or perhaps, even as strange as it may sound, a discrimination against a certain type of technology. So one of the things that I love and hate are the ever improving interactive voice systems that you get when you call into a business these days. And when I did a quick search on the internet, one of the top searches that came back as a suggestion as I was typing it in was how to get around going around these automated call systems, because I want to talk to a person. So this is that essence in me as a human to want to connect to another human and not go through a series of prompts and responses. So there's a lot of work there, but there's the basic psychology of going human to human. That's something that we'll need to work through. And I think we will as the systems become more competent and can essentially give us what we want. I actually, not too long ago, came up against a more advanced system that when I called in, for the first moments or two, I actually thought I was talking to a person because it was a full voice system and it wasn't mechanical. And then I started picking up on the clues that this wasn't a person. But it gave me the idea of what this could be in a few years, where I have a very competent automated system that I'm talking to that just can't do a few rudimentary things, but can adjust to what I'm asking for, be able to give that to me. And I think that will help me socialize. So probably the biggest part of the socialization aspect is going to be on the human side, overcoming the usual cultural barriers that we have to adapting to something new. So I'm interested to hear what everybody else has to say on this topic. I think this idea of socialization for autonomous systems is a really good idea for a show, Sharif. Thanks for letting me comment.
Thank you. Thank you, Mr. David Schumacher. Mr. Marshall, what you want to add for today's dialogue?
Well, thank you, Sharif. And I agree with David Schumacher that this is a very interesting topic and an important topic because it's prevalent throughout society today. I like a lot of the comments that David brought to the table about socialization. I think that autonomous systems are affecting virtually every aspect of our society, and so any future designs that we develop need to be guided by a broad range of societal stakeholders. That's what I sort of take away from what David is talking about. And of course, it reminds me of there was a movie not long ago, well, maybe it's a long time ago, about the first astronauts that went up into space. And when the engineers were designing the capsule, the astronauts asked the designers, "Where's the window?" And they looked at him and said, "We don't need a window." And they said, "Well, who's in control of the spaceship?" And they said, "The machines are, not you. You're just going up for the ride." So this is kind of where we're at today. I don't know if anybody remembers that movie. I don't remember the title, but it was very vivid in my mind when David was bringing this topic up. And that is, I think humans are, it's an age-old story of adoption of innovations, which is part of my background, from both a psychological and a societal approach, not just technology. So when you bring anything innovative into the marketplace, and people need to adopt, there's a distribution curve that can measure that. It normally looks like a standard T curve, like the kind you use when you grade students. And there can be kurtosis, a shift to the left or the right on that curve. And I think when we run into society bucking up against an adoption of a technology, good, bad, or different, we have a shift or kurtosis to the right, and you have less people adopting in the beginning. So, but now, as David Schumacher's pointed out, this autonomous technology is prevalent not just in cars, as he pointed out, but also in healthcare, smart city planning, and these autonomous systems help us determine how society should run as a matter of routine. That's where it's heading. And I think that humans don't like it. because they feel they're not in control. And the classic example was when you call up an office, such as a government office in the United States, either state or federal, and you're calling, let's say, the tax authority, and they say, for this department, press 1. For this department, press 2. For this department, press 3. And you got like 50,000 departments. When you press 1, then you get to another decision tree. Well, if you're looking for this, press A or 2. And if you're pressing for this, press 3. And it just drives people crazy. And they always try to find a way around it, which is, I think, significant and telling on how autonomous systems have been adopted to date. But I predict, as David does, that this is going to change and modify, because as technology, and I see Hugh is with us, as I think as fuzzy logic takes place and takes over more of the development of technology over time, fuzzy logic, I think, will, and Hugh can talk to that, we'll see more of an opportunity for better interactions between people and machines. The machines are here, whether we like it or not. And the autonomous technology is here, whether we like it or not. So the question in my mind is how best to optimize it. And then I guess from a business point of view, for those out there that are looking either for educational opportunities or work opportunities, there are courses out there that one can study with autonomous technology in various aspects, whether it's healthcare or, as in my sphere, in the area of green technology and climate change. And I look forward to see if David Smith is going to share with us what the value of each of those segments might be, because I think it's important to understand that those values. And I don't mean to put him on the spot, but he typically does come up with those numbers. So I'll hand it off to the next person. But Sharif, great topic, and I look forward to the rest of the conversation here.
Thank you, Professor David Smith. We are waiting for you.
Well, Marshall, you picked a topic in here that I could give you 25 different values of different autonomous systems. And that's one of the interesting things actually about autonomous systems, is they touch so many different domains. I mean, if you look, for example, in autonomous vehicles, that's about a $200 billion marketplace just for autonomous vehicles. But then if I go back and really look at autonomous systems and some of the areas which you and David have been talking about reach into autonomous systems in many other domains too, and particularly some of the software domain, you see that the market size is actually huge. But, if you begin to look at autonomous systems, and I kind of group in autonomous and intelligence systems in the way this is being put together. And there really are systems capable of adopting and learning based on feedback and data from their environment. And that is one of the keys as you look at autonomous systems and really how those autonomous systems can work with their societal impact, is that they do have to take the feedback from the area around them, from society, from the devices that they're working with, to begin to have an effective set of societal benefits. And, to benefit society in applications domains, we've talked about some of their transportation, health, social care is an area for autonomous, environmental presentation, enterprise productivity, manufacturing productivity, communications. Autonomous systems have been used for a long time in network optimization and power grid optimization and adaptation. You're beginning to see this type of autonomous and intelligent system being used in agriculture and really even in entertainment lately. And there's been a lot of recent advances that have really made this possible and have accelerated it a lot. We've talked about machine learning on these before. Marshall mentioned some of the technologies. I actually go beyond and say deep learning is one of the things that is pushing autonomous systems further and further down the road. And the ability to not only have machine learning, but deep learning and begin to put massive neural networks together are pushing this further. Signal processing has gotten to the point where we can now do real time versus near real time, which didn't do it. Our ability to look at sensors and digital sensing. We're seeing embedded systems, our data science, our algorithms have tremendously advanced. And you're beginning to see the fact that we have taken the concept of cloud computing and have morphed it to really be edge of cloud computing, which keeps the data processing needs down, which keeps the latency down and keeps the bandwidth needs into a reasonable point. And finally, if I look at voice, image, and pattern analysis, those have really stepped up to enable the autonomous and intelligent systems. There's great promise here, but there's also possibilities for privacy concerns, legal concerns, ethical concerns with the systems. We are seeing today, particularly, privacy challenges, trust challenges, and the issue of data transparency and ownership as we begin to look at these systems. And, as David said earlier, when you go into some of these new autonomous systems and employing some of the intelligent chatbots, it's hard to discern. But by the same token, it's hard to discern where all the data they're beginning to use with you to communicate comes from. I'm planning some trips and have been online with way too many autonomous systems lately. And, I love it that I can now log in, I can call or log into, for example, American Airlines. It doesn't even ask me for my Advantage number anymore or anything, because the systems there are intelligent enough that they track me enough that they knew who I am. And instead of saying log in, it says, here's your next flight. What do you want to do? So these autonomous systems are really getting to the point where they're almost treating me as though they have my digital twin in some of these systems. And that is going to be one of the ongoing privacy concerns I think we're going to have to grapple with these. And you're seeing, for example, over in Ukraine that they are now using photo images from people to identify the dead. That came out of the social media side. There was just today the announcement of a huge fine against a UK company that has scraped your face images off of your social media and is selling it to police departments and national governments to be able to track you even more facial recognition through autonomous systems. So it's a great area, a lot of happening, but there's a lot of privacy and security concerns on the other side too. So Marshall, didn't cover all your markets with the money, but just with the example of what's there, you can see that it is a huge market for this type of autonomous and intelligent systems, and their impact on society because of the pervasiveness of where they're being used today is huge. So Sharif, thank you.
Thank you, Professor David Smith. Now I request Professor Donald.
Hi. If during the show I have to jump up for a little while and disappear and come back, they're pouring a new concrete in my patio, and they may have questions, and I want to make sure they do certain things right. It'll only take a couple of minutes, but I'll disappear and come back. I listened to all of this, and I want people to realize that autonomous systems are not anywhere near as advanced as we'd like to think they are. Like the kind of one of the issues goes all the way back to a guy named Norbert Wiener during World War II, and he worked on the question of basically trying to get being able to shoot down airplanes or shoot from a deck of a moving ship. So basically the ship was moving around, and so what he needed to do is to take the gun and have it move in concert with the ship. So he needed feedback from the ship, and in order to keep the gun steady so that they could shoot down airplanes and things that were trying to get the ship. And he called that technique cybernetics. And so he invented that name to do this. And to this day, you've got cyber everything, cyber warfare, cyber this, cyber that. That all came from that particular thing. So basically then at the core, it's the question of feedback. And so fast forward to now, you look at Amazon warehouses, which are a thing that you'd love to have, that would love to be perfectly autonomous, and they're trying their best to get them to be as autonomous as possible. And so what winds up happening is, imagine that you have this giant warehouse with things on every shelf, these little cubby holes with things in every one of them, and you want to be able to go in, get the stuff out of the right cubby hole, put it on a conveyor belt, have it go down to a place where you put that stuff in boxes, have it take it off a conveyor belt and put it in a box. Well, things are all kinds of different shapes and sizes, and it may not be in the same place in the cubby hole. So it has to be smart enough to realize that, well, gosh, I have to go half an inch over in this cubby hole, or a quarter inch this direction in this cubby hole, in order to be able to grab it and put it on the conveyor belt. And the box that I'm going to put it in isn't centered exactly where this box is supposed to be, so I have to move it a little bit over. Or this particular item is shaped in such a way that I have to rotate it or somehow orient it to get it in this particular box. And they haven't figured out how to do that yet. That's why Amazon has to hire armies and armies and armies of people, because some of the issues of being able to orient things and put them and pack them in boxes hasn't been solved yet. They'll eventually solve it, but some of this is done, but some of it they haven't figured out. And we've got a long way to go. And I'll definitely want to point out that with almost anything, there's kind of a, what do they call it, 80-20 rule, where the first 80% is 20% is 20% of the work, and the last 20% is 80% of the work, or maybe even a 90-10 rule, which is that the last 10% is 90% of the work. And with speech recognition, we have these voice jail thingies. I know enough technically that when I call for technical help, I don't need to go through a thing that asks me if my device is turned on, if my device is plugged in, and all the different questions that these things ask you before they'll let you talk to a human being. I mean, I am so frustrated by the time I actually get to somebody. There's never any question in my mind that I'm being tortured by a voice system. It doesn't. There's no like world where what I'm talking to is anything that could possibly be a human being. And you're like, and it doesn't really understand language in any particular way. So when you talk to Alexa, what they do is it cheats, because you have to say, Alexa, do X, Y, Z. And so what that does is it makes sure that the first word is a verb. And because the first word is a verb, the parser knows what the rest of, or it doesn't really know because it doesn't parse it, but it makes a pattern that's easy to recognize. And I'll give you a couple of examples of where where the 90% of the work is in speech recognition. If if you basically say, well, it's hard to find a system that will even do this, but you can go to the GPT-3 site and find and fool around and get to this if you try. But if you say, Sally helped Mary with her homework, and she appreciated it. Did Sally appreciate Mary, or did Mary choose one? Sally appreciated Mary, Mary appreciated Sally. No speech recognition system can get that right at all, because they don't have any concept of the world. They don't have any concept of relationships, of those kinds of relationships as we do as human beings. And we don't have any idea how to get that to happen. Another one that's fun that you can do is go to the best translation system that's ever been made in the world. And if you know Spanish or French, translate this, try translating this. Put the box in the pen. Put the box in the pen. And in Spanish, it basically says, what is it? Poner la, I forget how to say box in la pluma, which means the feather. So it basically says, put the box in the feather. And feather is Spanish for pen, like a quill pen, because it can't figure out that it has to be like a pig pen or a play pen or something big enough for a box to get in. It can't figure that out. It has no way of knowing anything about the world. And we as human beings are constantly forming hypotheses about the world. So like if we say John and Fred walking along together or jogging along together, and they'd had a big fight, and they've been friends, and they had a falling out, and we knew they were so mad at each other, but yet we see them jogging together, we think, oh gosh, they made up, they must be friends again. Well, it may not be true. They may be jogging along because that's a way that they know that they can discuss dissolving their business relationship without hitting each other. I mean, there could be all kinds of reasons that they're doing it. But we guess, we out of a number of possible hypotheses, we pick one hypothesis and we go with it. That's called abduction, which is reasoning from the best hypothesis. And it's, in a way, it's fuzzy. It's a kind of fuzzy logic, because it's fuzzy in the sense that there's more than one possibility, but it's actually a formal logic. There's three kinds of formal logic: deductive, inductive, and abductive. And computers can't do abductive at all. They can't guess. They can't form hypotheses. And we don't have any idea how to get them to do that. So they really can't be autonomous in any sense that's meaningful. They can only do what we ask them to do. And even in deep learning, what they're doing is they recognize patterns. And I looked up, I'm really excited by what they're doing with autonomous vehicles. But the way that they do what they do is that they have a Waze-like system where all of the cars are continuously mapping the environment, and they have a shared map. So they're working off a map that they have. They're not reasoning about the environment. They're following a map, and which is not reasoning. It's the same as picking out the trying to pick out the things off a shelf in Amazon and put them in a box. It's not reasoning in any way. And if you want to look at it, realize that the cities that they're doing in it, New York City, Munich, places like that, they may seem chaotic, but I've been in those cities, and people pretty much obey traffic laws. I'm going to be really interested when they try and do it in St. Petersburg, where people don't even pay. A red light is not that significant. I mean, people just they go. Sometimes they stop at them, sometimes they don't. Go to Istanbul, where people drive on the sidewalks, or Vietnam, where there's motor scooters going in every direction, which way, and there's no predictability about what's going on. Or in rural areas where there's not enough mapping to be able to keep the maps up to date. That's again the 90-10 thing. We can get the easy 90%, but 90% of the work is going to be in the last 10%. So I think that it's really cool. I think that the 90% that we're doing is insanely great, and I think all of the things that people have said about how they're going to affect jobs, how they're going to affect privacy, all of those things are valuable and worth thinking about. But I also think that the whole thing, that the idea that we're going to have to worry about socializing them and things like that is giving them a lot more credit than we're not anywhere close to being that far. I mean, it'll be hundreds of years. So that's what I have to say. And if I have to run, remember, there's concrete going on outside of my window right there.
Mm-hmm. Mm-hmm. Thank you. Professor Ching.
Yeah, I haven't heard the technical details, so let me, this time. So usually I listen to other people to give technical details, so I don't have to say anything. But this time, let me give the technical detail. You see, AS, autonomous systems, it's a technical term. Okay, it's really referred to BGP, border pass gateway protocol. Actually refer to protocol. Okay, let me start from the beginning. Okay, what we have is a hub, switch, and routers. We want to get to routers because we want this autonomous system is run by routers. Okay, hub is just connections. Then you have switch, which is there's intelligent switches. Then there's a router, which will take information, knowing where things are going. Okay, so that is half of the part that gets things started. Actually, before that, we have internet protocol, IP address. Okay, IP address and the routers form this foundation, technical foundation for this autonomous system. Okay, the name is, they use this name for this BGP is it's probably confuse many people, and they think autonomous system should apply to other things, driverless cars, robotics, but basically that's where it starts. Okay, so we have the first thing to consider is the path vector routing protocol. Okay, an example is this what we are looking at, this border gateway protocol. Border gateway protocol is probably the most popular item in all this list of technical stuff. Okay, example of path vector routing protocol is this BGP. Okay, you have to use all these similar names to get shorten your talk. Okay, the person who really contribute to the path vector routing protocol is Behrman and Ford. Okay, the reason for this Behrman-Ford algorithm is to make sure that this routing will not go back to itself. Okay, once you have that, then you put it safe. You start to go into this internet or this route map. With the BGP rank filtering, and also they use IP prefix list. Okay, IP address is a list of numbers separated by dots, then separated by // then there's the end. At the end is the length of this address. So most quick search would just use IP prefix and the length. Okay. And so other things involved are the internal service, internet service provider, which play a role, which is really a AS. Okay, it is one of the example of AS. Internet service provider is an example of AS. AS stands for autonomous systems. This is the subject we're talking about. Then there is for this system, there's a interior gateway protocol and exterior gateway protocol. Interior gateway protocol is just what's going on inside the AS. External is what's outside. So all these things, AS systems, there's hundreds, thousands of AS systems, which must communicate with each other. And they will use filters for trust and distrust. They will have permission and the denial of IP prefix. They have a prefix list. So this, the system, to get back to the original AS autonomous system, there are only three steps they take. The first is initiation. The second is sharing. Okay, they try to share. Then once they see the sharing is okay, then they autonomously update. Okay, they have a software there. They autonomously update which AS they want to associate, which IP prefix they want to include in their IP prefix list. What is to permit, what is not permit. They have written down all these rules. If you satisfy their rules, you get in. If you do not satisfy their rules or regulation, you don't get in. Okay, so this is what they call an autonomous system. Okay, this all relate to internet router. Okay, so the reason I have to know all this is I'm one of the most critical person of the whole internet system. Okay, I think there, basically what we need to do is start with value consideration. Okay, then value means cost. Okay, what they are doing today is incorrect, resulting in every year everyone has to pay $15 per year for the internet address. Okay, which should be autonomous and free. Okay, and at most maybe $1 per year, something like that, not $15 per year. So that is the conclusion. And now I start to say what I need to say. Okay, with this out the line, what they need to do is two things. First, use the complete automated software to write their software or to write their routing table. How to control their routing table. There's a 500,000 addresses in their table. So this is a big item, and how to automatically do it. The reason you want to complete automated software is you want to keep everything clearly open or closed. Everybody knows everything from the start. Okay, complete automated system start from the most fundamental point. Then it derives all the software. If you write a software with complete automated software system, you know exactly what it is. It's completely open. Okay, and eliminate all the technology in computing. In other words, you don't need to learn source code. You just go to a computer. Computer will ask you, one is something, one item, one, two, three, four. You just choose. Okay, based on your native language. Okay, you can say one is for calculating, two is for print. You just choose. Okay, one choose, one print. Okay, you print. You just choose based on your native language. You make choices that you get down to a place where you say, okay, I want to print this. You write down where you print. The computer will write the software for you. Okay, after you do that, if you have one tree, you go to some place where they will perform the action. The place you go to is another address. It's called universal permanent number. Okay, this number is remembered by the complete automated software. So all the technology has been transferred into universal permanent number, and all the universal permanent number are remembered by the universal software. So everything is open. There's no learning curve. Okay, and this should definitely apply. Both this UPS and UPN should be applied to the internet system. Today the domain network system, naming system, domain naming system, and they use English. Okay, all this is to us is so wrong, and they charge us. That's the worst part. $15 to charge us. Okay, which should be everything should go into automation. It's complete automation should be complete open. There's no secrecy. Everyone should be able to know it. Okay. If you want something confidential, closed, you make it clear which ones are closed. You put password, you put encryption into it. So everything is open and closed. Okay, eliminate all technology. Another thing we need to put into this, when we have the system built, there will be problems. So we need to introduce fuzzy logic to expand the range of tolerance and to sacrifice precision and rigor. Okay, I think Don mentioned 80-20 rule. Okay, this is an example of fuzzy logic. In fuzzy logic, you just do the 20, then you forget about do the 80, then forget about the 20. Okay, 20, 80 is so easy to do. Okay, you always do the easy part first. You just neglect all this precision. Okay, precision is costly. Okay, so combination of UPS, universal permanent software, and the fuzzy logic should be applied to all this name. I have recommend to CAN, CANN. Okay, CAN. Okay, the organization who's supposed to be in charge of all this. Now it moves to MIT. By the way, MIT, Robert Wiener. Don also mentioned Robert Wiener from MIT. See, I was there. He was there when he's alive. Cybernetics. So basically, I've been talking to Ken about switching their IP address to UPN. UPN is all remembered by UPS, so there's no technology. This guy IP address is an integer name nobody can remember except the person owns it.
Sir, in between 1 minute, you finish because I have to give chance to the other speakers for concluding remarks.
Yeah. Okay.
Yes.
Okay. Yeah. So basically, we'd like to sell 18-digit UPN to Ken for just 0.1 cent. Okay, $1 you can buy 1,000 this number. Okay, so eventually I think when the society become rational, they switch to our system. Okay, based on this fundamental idea of complete automation and also fuzzy logic. Okay, this is actually area that should switch, more than any other system, because this is really a virtual reality system. It's just an information system. It does not involve laws of nature or anything. So it's all logic. Okay.
Thank you,
that's-
sir. Thank you, sir. So, David Schumacher, what's your concluding remarks and for today's session?
Yeah, I enjoyed the comments by all the speakers. I tried not to, I wanted to focus on the societal impacts. That's the part that's of most interest to me. Now, I have a background as a systems engineer, and then later integrating that into businesses, selling technology to businesses, especially small to medium-sized businesses. So I admit that I can be a bit of a geek about the technical details, and I really enjoy that. But I found that the people that buy the technology don't. They're interested in what can this technology do for me. So I had to learn not to talk about the things that interested me so much, uh, but what interested to them and what's the value proposition for them. So I see that as the same way as we're talking about autonomous systems and their impact on society. Autonomous systems are here, as has been said, and their use will be expanding. But what's going to keep that expansion at a slower rate or maybe make them not go into certain areas will be resistance because of not seeing the value of what they're there to do. So it's the value to businesses, governments, and to individual people, because I think there'll be autonomous systems that you and I will be able to buy and implement to do various things for us, whether it be home automation or whatever it might be. But they have to have a perceived value to us. We have to see how it is that we can benefit from using these things. So what's the danger? I think the danger is going from the stage where an autonomous technology is good enough to start using it, but not really good enough that everybody really enjoys its use. We kind of beat the issue of voice answering systems, for example. Why did business adopt those? To lower labor costs in call centers, and there was a significant business advantage, and they had to look at the risk reward proposition. If I use these voice management systems, a lot of my customers are not going to like them, and they might go to a competitor that doesn't have that system. How many of those can I let go to the competitor but be able to drive my prices down because I can reduce costs and be able to better serve? So maybe people won't like them, but they'll stay with me because overall they're still having a better value proposition. So this area between a technology is good enough to deploy, it's going to save my company money, maybe indirectly I can convince my customers that it helps them because I'm keeping their costs down or giving them 24 hours a day, 7-day access that they wouldn't have otherwise. But it's not, gee, I really want to call in and use the system. As the system develops, or and becomes more seamless, and the value of using the system becomes something that we don't think about, then acceptance is there for us. So the reason I think that this space between good enough and when it's really good is the area is because some things stick with us. We tend to stereotype or we don't take in new information. Like the last time I called a company and got an interactive voice system, I really hated the experience. So I hate this experience before it even starts. So I'm going to try to find a way around it. Do I press 0 and get an operator? How do I abort their intention? And I'll admit that I've done that myself. As I mentioned, I work in a lot of technical areas, and in some of those technical areas, I have relationships with companies that let me go straight to level 2 or level 3 support, where I can bypass the initial customer service experience. But that's because I have a relationship with that company. And some of the value that I might give my customers are, let me handle these issues for you because I can go around that inefficient first part that we don't want. It's sometimes even now at level 2 or level 3, there's still a triage system. And I really rebelled against that based on my prior experience. But I'm starting to find that at some of those that they're pretty good because they're expecting someone that has privilege to call directly to level 2 or level 3 is going to ask different questions than the person that calls to level 1 support. So the algorithm is better suited for that, and it provides a more satisfactory experience and can be faster. So I have to be trained to not stop thinking about how things have been, but continue to look forward to the progression as things move forward. So this spot in between is the dangerous aspect. And I look forward to when we don't even have discussions about adoption because it's just taken as a matter of fact. And then we're on to talking about adoption of some other technology. So that will always continue. But yeah, autonomous systems are with us to stay. And I predict that over time that they'll get better. And it doesn't really matter what the underlying technical details are, even though they matter greatly to me and it matters on how we can deliver them. The customer, the business, who's ever employing this, whoever's buying and using the service, they're just interested in the result. And that's what we need to work on. Thanks, Sharif.
Thank you. Thank you, sir. Mr. Marshall.
Well, Sharif, I think this has been a terrific topic, and I like everybody's input on it. One of the things, before I get to my final concluding comment, I would say that, and I think Hugh brought it up, about the use of fuzzy logic. Fuzzy logic plays a big role for what David Schumacher was talking about, the acceptance of autonomous systems, because in many cases right now, as Hugh pointed out, these technologies in many respects are not really being deployed properly, or if they are, they're kind of getting a rebellion by the people who are using them. So the users have some problems. I think everybody here has kind of expressed some of their own personal experiences with these autonomous systems, especially in phone systems. But also maybe we've seen it with automobiles, and and as David Schumacher pointed out, they will get better. They're here. But I think one of the solutions to this is as Hugh pointed out, is fuzzy logic, because typical logic, as Donald pointed out, is, it's either 0 or 1 is typical logic process. Fuzzy logic plays in the role where there's ambiguity, and humans have built into them a logic of their own, a fuzzy logic that is given to us by nature, that says, we don't accept everything as it is, whether right or wrong or true or false. That's the way we perceive things. It's our perception. It's our sensory input in our way we perceive, which is not the same as machines. Machines are getting there, but they're not quite there yet. So applying truth values, as fuzzy logic does, can play a heavy role on that. And I'm sure that it's people like Hugh that could come to the table and bring some of the solutions from a instructive force of using and how to apply fuzzy logic. From my own perspective, from a 30,000 Google Earth view of autonomous systems, I would say that basically the management of autonomous systems needs to be at the crossing of science, technology, society, policy, governance, and psychology, human psychology, because humans don't operate like machines. And we try to make the machines emulate humans, but humans have, as Hugh pointed out, indistinguishable logic that is fuzzy logic, right? Good, bad, or indifferent, that's what we have. And we all have it in our societies, and each society is different, and each culture is different. So how do you attenuate for those things? And so, and I liked when Donald pointed out the difference between an instruction in Spanish that had to do with a pen versus a pig pen or something like that, a box. So, so even linguistics plays a role here. And there are fuzzy logic capabilities for linguistics. We know that because if you've ever studied a language using this new technology, which was developed by Professor Pimsleur, in which you learn a language backwards kind of function, algorithm, That's how people can learn using the human mind. Instead of adopting the language learning skills the way we think they should be, he discovered that they have to be attenuated for that fuzzy logic that humans work with. And so, again, I think my takeaway from this conversation is that everybody's got their role here, and we need to integrate the science, the technology, society, policy guidelines, policy development, and governance along with human psychology. And on that note, I pass it on. Thank you. Sure.
Thank you, Mr. Marshall.
Great topic.
Professor David Smith.
Great session, Sharif. Always love the autonomous systems, intelligent systems really based on how they understand the world. I was fortunate back in the early 90s to be an executive at the MCC Consortium, which was the computer industry in the United States trying to recompete globally. And in our artificial intelligence program, we had a researcher named Doug Lynette, who was a pioneer in AI. And actually, while he was at Stanford before he came to Austin, was on covers of academic journals saying he was one of the fathers of AI. But he pioneered a concept of cognitive intelligence. And while he was at MCC, he started a program called Psych, which was common sense intelligence. And the common sense is one of the things that is still part of the Holy Grail as we look at autonomous systems and intelligent systems. You know, one of the great examples was if the street is wet, how would an autonomous system, an intelligent system interpret that? Was it rain? Was someone spilled something? Was it the sprinkler system on? What was that? And that type of common sense that is inbred in humans, we're still working to embed it in the intelligent systems that are running our autonomous systems. And it's one which I think we're still going to be working to advance as we go through the future. This type of common sense is often known today as cognitive intelligence. And this cognitive intelligence is going to be really extremely necessary as we begin to take these autonomous systems and take it on to the technology group and map them across all the domains now. Most of our deep learning, most of our fuzzy logic is domain-based and then application-based, and we need to get to this common sense base to really have these happen. It's like Donald was saying, he can recognize pretty quick when he's talking to a chat box, and most of us can't. I will admit, if I am talking to a airline chat box or a hotel chat box, I start asking for agents after probably the second question and begin to try to go that way. And if that's not working, I'll start hitting 0 on my phone pad to try to go ahead and get around the system that we've all learned to game. And we've learned it because we're applying our common logic. And that's still where we need to go with autonomous systems, is to be able to take the things that we know and embed them in the system. It should be able to recognize us as where, like when David says, well, I should jump to level 3 tech support because of what I know. I'm kind of the same way. When I go into a tech support line, I always ask at the level 1 tech, please bump me up. I've already tried everything your script's going to tell me to do. And we can waste 15 minutes with me saying, yes, I've already done that. Yes, I've already done that. Or we can just get out above where you can't go. And that's where we still need to go. We need to bring that into these autonomous intelligence systems because for it to have the true societal impact that they're capable of having, they have to behave more within our culture, within our knowledge domains, within our common sense domains. And I think what Dr. Lynette, what Doug was trying to do way back then, which we didn't have the computer power and the AI advance far enough to do it, is honorable because that's where we are today. And we're seeing that deployed globally in so many industries now, and in so many different hardware systems, and so many different software systems, that it is really a time to come, and one that can be applicable globally in any developed or developing nation. It's going to touch all of us and have really great opportunities. But Sharif, thank you for letting me be part of this today.
Thank you, sir. Professor Donald, what's your concluding remarks?
I want to clarify a couple of things. First off, we've been talking about autonomous machines and not autonomous systems, which formally autonomous systems are an internet specific subject, as you brought out, but autonomous systems and autonomous machines, in my mind, mean the same thing. So I also, when you talk about autonomous systems in society, my brain goes to autonomous machines in society. So I definitely interpreted it to mean that. When I want to really clarify to everybody that logic is not ones and zeros. There are three kinds of logic. There's deductive logic, which is ones and zeros. It's either true or false. There's inductive logic, which is logic that's basically which is probabilities. It's most likely true, or it's most likely false, or it's false, most likely true a certain percentage of the time, or most likely false a certain percentage of the time. And that's the kind of logic that deep learning uses. It's not predictable because it's based on experience. And that's the kind of logic that we use to a degree to be able to recognize patterns in nature. And it's the logic that we use to do facial recognition, because when we look at enough faces, we say the probability that this particular pixel in this particular picture is a face is higher. And as we look at more and more faces, knowing which faces that have been marked for faces, we start learning that the probability of this particular pixel being in a face becomes higher. So that's the way deep learning works. It's inductive, but deductive systems are not true and false systems. And then the third type of reasoning that is used in logic is called abductive reasoning, and that's the reasoning that David was talking about when he was saying the question of being able to understand is basically forming hypotheses. So the street is wet. Was the street wet because it was raining, or is the street wet because the sprinklers were on? Well, I mean, how did the street get wet? Well, there's not a cloud in the sky. So we as human beings, we go to the idea that, well, it isn't rain that caused it. There must be some other explanation. And so we search for a different explanation for it. That ability to do that, to realize that no, that explanation can't be right, we need to search for another explanation, we have absolutely no idea how to do that. There's no paper, there's no nothing that has ever been done that gives us a clue on how to do that. But that's absolutely key. So when we're talking about fuzzy logic and saying to ourselves that human beings make logical things that aren't deductive logic, well, that's well known, and that's been discussed for more than 100 years. well more than 100 years. And if you're interested in it, I found a paper that's actually understandable by Charles Sanders Peirce, who actually identified this, and it was an early paper by him where he still called it hypothesis instead of abduction, and it's called Deduction, Induction, and Hypothesis by Charles Sanders Peirce, and he explains how these different types of reasoning work and why they're different than each other, and why they're all types of logic. So I would look at that. But then back to society. What we're going to keep making incremental change. Well, what that really indicates is that we're getting really good at, computers are getting really good at deduction. They're getting really good at induction. We don't just look for patterns in the world blindly. So when we train deep learning systems, we do it in a structured way. We say, look for faces. We train it to look for faces. We train it to look for different kinds of things. We train it. We train it to play Go. A machine that knows how to play Go can't play chess. We train it to do the specific tasks that we want it to do. When we built the Large Hadron Collider at CERN to look for the Higgs boson, we weren't randomly whacking protons together in the hopes that we were going to find something. We had a darn good idea of what we were looking for. So that forming hypotheses is something that human beings can do. That's something that we do well. But the computers can assist us incredibly well. And then once we form these hypotheses, the inductive step, that's the CERN's doing the inductive step that allows us to be able to look at things and examine the world around us in ways that we could never, ever do before. And so if we're clear about what we're good at and realize that the computers aren't going to do some of the things that anytime soon, we don't even have any idea how to get them to do it, and realize what they're really super good at and use them to help us get better at it. I mean, I can't even imagine how valuable they're going to continue to be to us, and they have been, and that's what they are doing now, and they're just going to get better. So,
Thank you, sir. Thank you, Professor Ching. What's your concluding remarks?
First, I agree with Donald very much on this point of the title of our talk. The title of our talk probably should mean autonomous information systems. While there's also another autonomous mechanical systems. They should be separated into two. I really think there is this big confusion. Okay. But regardless of that, both of them, my concluding remark refer to all this autonomous system. You see. So let's start with a subject everybody talking about now, this fuzzy logic. You see, I'm the heir to Rafi Sadeh, the father of fuzzy logic. Okay, he kept me with him for the last 10 years of his life. So he wouldn't let me go. Anytime if I didn't attend one of his talks, he said, "Where were you?" He said. So I just been kept by him for 10 years, meeting him during a round table and also probably Sunday brunch. You see, just meeting and thinking, try to get in what is he talking about, fuzzy logic. Okay. So basically, I just, I'm saying this as authority. Actually, nobody else understands Sadeh. Fuzzy logic is the final stage in the development, say a robot. Okay, to solve open-ended variant problem, which change continuously to infinity. For example, robot. After you build a robot, the next thing you need to do is to expand their range of tolerance. When they see a car coming, they should hide. Okay, they should run away. You see, so the robot doesn't have as much range of tolerance as humans. Okay, this would distinguish the basic idea of fuzzy logic. And try to develop robot to a human. Even humans need lots of improvement. Human is not constructed perfectly. Okay, so another word, the human is a variant. I talk about this open-end variant problem. The problem will change continuously. Okay, this is a big problem in the universe, I bet. Okay. People try to improve the next model of living species, living system. Okay, so the final stage is using fuzzy logic to exploit the range of tolerance. In other words, we already give up on solving the problem exactly. We try to do the best we can. Okay, all this stems from one point, okay, being the heir to Loftus. I have looked into the problem as a scientist, mathematician, and a logician. Exact, complete automation has the problem of going into dead loops. If they're exact, they cannot exist in the universe. They cannot exist, period. Okay, let's look at quantum mechanics. Okay, the old notion before quantum mechanics, we think change from 0 to 1 is just jump from 0 to 1. But quantum mechanics make a much more reasonable process. It changes from 0 to 0 or 1 to 1. Okay, in other words, there's a transition period. Okay, this is fuzzy. Okay. Another, from the very fundamental point, we need to have fuzziness. If we don't have fuzziness, we have exactness, the convergence will go into a dead loop. Okay, this is very apparent in when I program my validation software. Okay, especially the stock validation software, I have to use a double loop. If you do not inject some fuzzy logic into the final convergence scheme, just convergence scheme, you get into that loop. Okay, you have to guess when it cannot get out, the human can intervene and stop the calculation and change some parameter to make the convergence fuzzy in order to make it work. Okay, it's not guaranteed. A determinate system is not guaranteed to produce a result. You also go into that loop. Same thing with this guy I mentioned. You see, Bellman, Ford. You see, they are solving this going into their loop. Actually, a route going back to itself is going into their loop. I think exact complete automation will all go into their loop. You see, therefore, in the universe, the foundation is fuzzy logic. The foundation of reality. Okay, anything that do not exist is outside what we observe generally. Is we cannot say much, but the reality is fuzzy because it's because of the reason I just gave. It goes into thinking. Thinking takes, you have old idea, new idea. In order to get a new idea, you have to go gradually, fuzzily go to the new idea. A person keeps saying, I'm right, I'm absolutely right. It's not going to change. Okay, you got to go in the fuzzy state. So let's get back to our real topic here on this autonomous system. The tolerance of hidden technology should be eliminated. Okay, this is a big statement. In other words, society should not have any hidden technology. Everything should be clear. If you have a software, you have a language, you have a program, anybody using it should see everything from the beginning, how the program was written, how it's documented, you see. And all this program statement language should be related. You see, this openness is very important. one way to eliminate technology socially is for example for software to pay for the cost of update. This is the exact statement that I made in a class action lawsuit. If you develop a
Thank you,
software,
sir.
you pay for the update. Okay, that
Thank you,
would,
sir.
yeah.
Thank
So,
you, sir. Thank you,
yeah.
sir. It's yeah. This is really great sessions, and especially we learn a lot of things about autonomous system, fuzzy logic, different industrial things, and how we can apply in real life and what is the benefit. I want to give special thanks to our honorable speaker, Mr. David Schumacher, Mr. Marshall, Professor David Smith, Professor Donald, and Professor Ching. I request all of our audience, please share our content as much as possible. Beside that, you know that we are working with Central Bank of Bangladesh. Uh, Today, we collaborate with Energy Ministry, ICT Ministries, and hopefully we can bring more important dialogue and more important real life projects. And hopefully we will work together and we will, the developing nations and developed world will work together and we will minimize the gap. I request all of our audience, please share our content as much as possible with your government, with corporation and academy. Today we finished 553 episode. We want to develop more episode with all of your contribution. Thank you. Bye bye and take care.
Take care,
Bye
y'all.
bye.
Take care. Good session. Good session.
Bye, Sherman. Bye, Don. Bye, Dave.
Good session.
Okay, bye, Sherman.
Good session, Hugh. Like your comments. Thanks
Yeah,
very
thanks.
much. Be well. Bye bye.